Well, after the great internet outage of August 3rd, 2020, no surprise, weird things happened there, huh? So my internet feed is back up. It's not really where it should be. So I'm going to make a couple of short presentations just in case I have to go back and redo it because the sound quality may not be that great. So here we go with chapter 5, which is a little bit about the integumentary system, otherwise known as the skin, and its accessory organs. Might as well accessorize when you get a chance, right? So the integumentary system is mainly the skin, and the accessories are hair, nails, a variety of sweat glands, and the sebaceous, or otherwise known as oil glands, associated with hair follicles. The skin consists of two regions, the epidermis and the dermis. Epi, of course, means above or on top of. So that's where we find the epidermis, above or on top of. The epidermis is epithelial tissue, specifically stratified squamous of the keratinized variety, and as such is avascular. I don't think I have to define that word for you at this point. The underlying tissue is the dermal layer, which is mostly connective tissue with a lot of collagen fibers and maybe a few other fibers in there. And also, it's well vascularized. Now, the hypodermis, technically not part of the skin, is also called the subcutaneous layer. Hypo below, dermis, the dermal layer, below the dermal layer, and subcutaneous. Cutaneous means skin, so subcutaneous is below the skin. Maybe you have visions one day, or maybe you do this already at work, of giving somebody a subcutaneous injection using a hypodermic needle. So since it's not part of the skin, it's intimately associated with it, though. Adipose tissue predominates, that's fat, and acts as insulation and also protection. Let's go through this diagram of the skin and talk about a lot of the parts of it from this diagram. We'll start up here with the epidermis, and then we see the dermal layer has two regions, the papillary and reticular, and we see the boundary is wavy. Dives down in here at the hair follicle. And a papilla is a finger-like projection. And so the dermal papilla are these finger-like projections of the dermis up into the epidermis. And that's what is characteristic of the papillary region. The reticular region is the region below the papillary layer. There's stuff in here. So let's take a look at each one. And then, of course, below is a subcutaneous layer, and there's arteries and veins that run along that boundary with branches that lead up into the dermal layer, but not the epidermis. And they even extend up into the dermal papillae. So the skin is an organ. You might say, wait a minute now. I don't understand the stomach is an organ, the heart is an organ, the lungs are organs, but how is the skin an organ? Excellent question. I'm glad you asked. An organ is a group of tissues cooperating to perform a function. So here we have epidermis, which is epithelial tissue, connective tissue in the dermal layer of a variety of types. We've got the fibrous connective tissue. We've got blood vessels with blood in it. We even have nerve endings. And these nerve endings, nervous structures, shall we say. What do we have here? We have nerves going up into the dermal papillae for our sense of touch. We have nerve endings on each hair as part of the sensory function as well. We have, not shown in this picture, but Meissner's or tactile corpuscles, also sense of touch up in the dermal papillae. We have the lamellar, lamellated, or Pacinian corpuscles, which are involved in the deeper touch and vibration, a little bit lower, deeper in the dermal layer. So lots of nervous tissue, and we even have muscle tissue. Each hair follicle has a muscle attached to it called an erector pili muscle. Pili is another term for hair. We can't just call it hair. We got to come up with a term that makes absolutely no sense, right? So pilus is a hair, and pili is plural. And the muscles that attach, what this does is this gives us goose flesh when these muscles contract. When you get scared or something. So the skin truly is an organ by its definition, a group of tissues cooperating to perform a function. And in this case, we have all four tissue types cooperating to perform the functions of the skin. All right, let's continue our trip around here. Okay, the hair root is just like the name implies, like the root of a plant, the deepest part. The follicle, the hair follicle, is the whole part of the hair below the skin, and it becomes a hair shaft or pilus when it is above the skin. Then we also have a gland. It looks like a clump of grapes a little bit that surround the hair follicle and have a duct that empties into the hair shaft, or this space in between the follicle and the hair. Here it is cut away. These are the sebaceous glands that secrete oil that lubricates, keeps the hair from drying out. Another reason why you need to wash your hair at least once a month or so. Ew. Then we have the eccrine sweat gland, which is an exocrine gland, like the sebaceous gland, that empties its secretions, regular old sweat, onto the surface, free surface, in this case the skin. And we see openings, there's a couple other ones over here, most numerous of the variety of sweat glands. Now this is a diagram of regular skin. On the model that you might have seen from the lab, it would be labeled the skin of the scalp, which is just an example of regular skin. We have three types of skin. We have the regular skin depicted in this diagram. We have thick skin, which has a thicker epidermal layer found in areas of abrasion like the palm of the hand and the sole of the foot. And then we have the special gland that only occurs in the armpits and groin, or axial or inguinal areas, and that's called the apocrine gland. And we'll get to it a bit later. The epidermis consists of keratinized stratified squamous epithelium. So that's multi-layer cell with flattened cells at the free surface, and they contain the tough protein keratin. We have four cell types that we find in the epidermis, and predominantly is the most numerous one is the keratinocyte, and its name tells you what it does. Cyte cell keratin produces this tough fiber, this protein that's fibrous, known as keratin. Major, most numerous cells of the epidermis, and they are tightly connected by desmosomes. Now, I know by now you remember what desmosomes mean. Talked about it a couple times. Talked about it during the cell junction part. Talked about it during the muscle in the tissue section between cardiac muscle cells. And these are the connections that hold cells together tightly like a rivet or a bolt and a nut. And that's going to come into play and be important a little bit later in the story of the life and times of a keratinocyte. That's right, life and times of a keratinocyte. They do have a life. Millions slough off every day. That means they come off. They're born in the lower layers of the epidermis, and as cells are lost from above and replaced from below, they move their way, they migrate their way up to the surface, and then along their pathway they die, and then eventually they come off. And they take with them DNA. So everywhere you go, everything you touch, you leave your DNA behind. So you gotta be careful about that. You see, I have a friend, believe it or not, I do. I haven't talked to him in years, but he's a police officer, detective in a little tiny town in southern Georgia. And he was investigating a robbery one day. One night, somebody broke in to the local dollar store. And note to self, if you're going to commit a crime like breaking and entering, burglarizing a business, maybe a place not a dollar store, or don't commit a crime. That's a better piece of advice. Anyway, so he was reviewing the security footage, and this guy came in, had a hood over his face, had head and face, so he couldn't see real well. He was wearing glasses and gloves. And so what did he do? He took the cigarettes, busted up the cash register, got about $30, grabbed a handful of lottery tickets, which as soon as you walk out the door, they're worthless because they'll turn them in as stolen. And so then he switched to the outside view, and as the perpetrator was walking away from the store, he took the gloves off and threw them in the dumpster. Well, Officer Friendly dove into the dumpster and recovered the gloves, and from them on the inside out, he was able to recover fingerprints and DNA. And not a big surprise when that information came back. The local police department was familiar with this person, and they went and found him real quick. So, had the perpetrator done one of two things? Had they taken the gloves with them and disposed of them somewhere out of sight of the security camera, wouldn't have gotten caught. Had he not burglarized a business, there would have been nothing to catch him for. So, what do you do? Anyway, the keratinocytes, in that case, sloughed off and took the DNA with them. We have melanocytes, which are I don't like spiders. Located in the deepest layer of the epidermis, what we'll know is the first two layers, stratum basale, the bottom layer of the epidermis. And their job is to produce the pigment melanin, which is packaged into these little bodies, melanosomes, and then they're transferred to the keratinocytes where they surround the nucleus and prevent it from the nucleus being damaged by ultraviolet light. Now, ultraviolet light is what we call ionizing radiation. It's an energy level above ultra visible light. And when it hits DNA, it can damage it. It can break it apart. And that's not good. It can lead to skin cancers. So the melanin absorbs the ultraviolet light, somewhat protecting the DNA of the keratinocytes. And there's a nice picture here a little bit later that shows these melanocytes. Then we have our skin's own security detail, the dendritic or Langerhans cells. And once again, here we go with a name change. It's been called Langerhans cells forever, as long as I can remember anyway. And then the last year or so, they want to change it to dendritic cells. Either way, they're macrophages, which are only get a special name because where they're located in the deep layer of the epidermis. And they're on patrol, literally, looking for things that don't belong, the usual suspects. And if they find something, they can phagocytize it and activate the immune system by sounding the alarm. And then we also get some sensory cells. Once again, been called Merkel cells forever, but let's go ahead and change the name. And there's that. Let's just change all the names. I had a conversation with my wife's physician about name changing, and I told him he was talking about one thing and that she has a minor issue with, and I said, they changed the name of that. And he was a young fella too, much younger than me, and he said he just shook his head and sighed and said, "Oh, they're always changing the names. I hate that." So I'm not alone. Alrighty, so thick skin, where we find in the high abrasion areas, hands, palms of the hands, and soles of the feet. Not the whole hand, not the whole foot. Contains an extra layer and has an extra thick outer layer. So starting from the bottom, this is the lowest, deepest level of the skin, is the stratum basale, basal layer. You see the word basal in there? Base is the bottom layer. Then we get the stratum spinosum, stratum granulosum, stratum lucidum, which is only present in the thick skin, and the stratum corneum is the outer layer. And so each one of these, let's go through them. All right, the stratum basale is the deepest of the layers. That's the one that's the basal surface of the epidermis, attached to the dermal layer. A single row of stem cells that actively divide, producing 2 daughter cells each time. So they tend to be of the cuboidal variety. When we see stratified tissue, almost always, very few exceptions, the basal layer is going to be cuboidal. Stem cell means that it can go on to become any of the different skin cell types, and mitotic is a term for cell division. So they're actively dividing. This is where the new cells are being born. And each time it divides, one cell heads toward the surface of the skin and the other one stays behind. Cell dies as it moves toward the surface, and I'll mention that here more about it and why in a minute. And as it makes its way to the surface, depending on how thick the skin is in that particular area and what's going on with that person, 25 to 45 days. So you're looking at just under a month to a month and a half that it takes to rejuvenate the entire epidermis. So it's also known as we're just going to call it the stratum basale. Let's just leave it at that. So most of these cells are the keratinocyte variety, and a few of them, not many, less than a quarter, are the melanocytes. Then we get the stratum spinosum. It gets its name because the cells start looking a little spiny, prickly like a cactus. It's a couple layers thick, and this is where the cells are still alive, and so the DNA is being protected by the melanosomes. The dendritic cells are wandering around in here, the Langerhans cells on patrol. And we have a picture of this in a moment. Stratum granulosum, the granular layer. It's also several cells thick, but they're starting to flatten out. And as the cells travel from the stratum basale, where they are born, up to the stratum corneum, where they are lost eventually, they go from being cuboidal to squamous. So in this granulosum layer, this is where they start forming the keratin, and they basically become a bag full of keratin in these granules that look like sand. Hence the name granulosum, or granular like, and think like sugar grains. And also then water resistant glycolipid that slows water loss. What that means is that helps keep the water, this layer helps keep the water inside the body. In instances where, like, severe burns, what are the risk factors for severe burns are dehydration and infection. And those are two of the things that the skin protects us from: infection and dehydration. Keeps the water in. Once the cells get above that layer, above the granulosum layer, then they start to die. And the reason they start to die is they're too far from the blood supply to get nutrients. So they starve themselves. They starve to death. Right now, each and every one of us is starving keratinocytes in our stratum granulosum. What did they do to deserve this? No, we should be thankful. They are giving their lives so that we can retain our water and fight infection. Now, in the thick skin, you get a layer called the stratum lucidum. Lucidum means clear. Have you ever had a lucid moment? A moment of clear thinking? There's stuff there. It just doesn't take the stain. And I don't know, maybe that might be in the picture. So clear, flat, dead keratinocytes that are there, but they don't take the stain. We only find that in thick skin. It's one of the things that makes the skin thicker. Then we get the outer layer, the top most superficial layer of the skin, the stratum corneum, like crown. And then they want to go ahead and call that the horny layer and expect that people don't laugh. Who would write that? Anyway, so it's like 20 to 30 rows, maybe more, in the thick skin of anucleate. The nucleus is broken down. The cell is dead. Keratinized cells. It's most of the thickness of the epidermis. And what holds them together are the desmosomes. So the cells are dead, but they're still bolted together. That way they don't come apart. Now, eventually the desmosome is going to degrade, and that's what's going to allow the cell to slough or come off the surface of the body. And even though they are dead, they can still perform their functions. which are to protect deeper cells from the environment. That's the number one function of the skin, protection. Second function, prevent water loss. The keratin helps hold the water in as well. It protects the deeper layers from abrasion and penetration. So if you scrape against something or rub your hands together, cells come off, but they don't damage the cells below. If a mosquito wants to come and bite you, it's got to get through this layer. And so this layer acts, and the skin in general acts as a barrier against biological, chemical, and physical assaults. Isn't the skin wonderful? We'll talk about what each one of those means. But let's look at this picture first. So here is a fingertip of a dermal papilla sticking up into the epidermis. We have the stratum basale, roughly cuboidal, looks more spherical like right here. But you got to use your imagination a little bit. That's the deeper layer. Then you get the stratum spinosum. You see they're starting to get little points on them. Somebody thought that looked like little bristles on a cactus. And then the granulosum layer, you can see where it gets its name. It's starting to fill up with keratin granules. And then above this layer, they die and they start to flatten out. And here's the stratum corneum, the superficial layer. And then we look over here at the diagram, and we can see here's a dendritic cell, macrophage wandering around, keratinocytes. You see how many more keratinocytes there are than the other cell type. Here's a Merkel or tactile cell attached to a nerve ending, sense of touch. Here is a melanocyte. Now, it said earlier, I said spider shape. If you look at this melanocyte, look at the processes of this melanocyte wiggle around in between all the other cells. And it makes this dark pigment melanin and then transports them through these processes to the surrounding cells. And all these little dark dots represent melanin or melanosomes. And they surround the nucleus. These absorb ultraviolet radiation. So that's a decent depiction of the melanocyte. You can see it's all the little processes. It's almost got as many processes as a osteocyte. All right, well, let's call that a presentation, and I'll wait a few minutes and see how that worked out, if it uploaded correctly. And if it did, I'll come back and make another presentation for you. So until then, arrivederci.